Welcome all to Dr. MDS Academy. Here I am going to show you an animation, critical thickness of insulation. What is it actually? In case of cylinder, we had seen in lecture that this is our solid, complete solid wire or pipe. Okay, over that we are having a something thickness of insulation we are adding. Okay, so finally, we had got for the case of cylinder RC is equal to K upon H naught. What is RC? Critical thickness of critical radius. So K is the thermal conductivity of this core wire and H naught is the thermal convectivity, convection heat transfer coefficient of the outer wire or air. Okay, so we had seen the heat transfer get increases then decreases. At RC we are getting the maximum heat transfer. So in animation here see we are having the two different cases, cylinder and another is the sphere. For the case of cylinder, see here RC formula is given as RC is equal to K upon H. Okay, so for the time being here K is kept at, say suppose at zero point 0.6 we have kept. Okay, and the H value we have kept is, suppose for example we have kept 10, so K upon H we will get 0.06 here. RC is equal to 0.06 for the case of cylinder using this formula K upon H, standard formula. Okay, so in animation see here the dot line is what showing? Dot line is showing that it is the radius of critical radius. Okay, so since we know that RC is directly proportional to K, here RC is directly proportional to K, so more is the K, more is the RC, or less is the H naught, more is the RC. So you can play with here. So more is the K, more is the RC you will be getting. See the value. Similarly in the graph you will be getting, okay, values. Okay, more is the K, more is the RC. RC means from center to this much distance. Lesser is the K value, lesser is the RC. More is the H value, lesser is the what? Lesser is the RC. See, in the real time the data is changing. So lesser is the H value, more is the RC, because H and RC are inversely proportional as we had seen in the formula. So this simulation, the code that I have run is okay now. So if you want to, what is Ri here? Ri is the this one, rod radius. See, as you are increasing the rod radius, okay, this black one Ri, okay, see what is happening. Okay, what is insulation thickness? This red one RC, from here to here, more is the value, more is the this. So as this colored red shaded region approaches dotted circle line, suppose for example here we are having a red shaded region. Now just increase it. See, this dot on the graph is increasing. What it is showing? The insulation increases heat loss, means the heat loss rate is increasing. See in the graph, as Ri is what? Ri is this one here, Ri is this one. As more is the Ri, the heat loss get increases. Okay, see here what is happening. So more is the R value, more is the, see, as we are increasing this, see what is happening, the dot line is going to the greatest heat loss value. See here. Now the currently the value, suppose for example I have set at 0.5. and let's say H value I have kept at 10. Okay, so 0.5 divided by 10 will give RC. So what we are getting? 0.05. So this is the 0.05 RC, critical radius. So as you are increasing this shaded region, means insulation radius you are increasing, this one more. Okay, more is the thickness you are going. See, the RC is increasing here. Insulation increases heat loss. Heat loss is increasing. Now it is showing yellow. What does it means? Heat loss is maximum. Means now this is the condition of here. Here. Now when you will increase this here, okay, what will happen? The heat mass loss decreases. Okay, just increase the or give more layer or insulation layer over this dark wire bare rod. So when you will increase, see, now the status showing is insulation radius heat loss or reduces heat loss, means it is obeying this path. Okay, so this I want to show you. See here what is happening. Continuously the heat loss is decreasing. Okay, so we can say that the radius of RC is only up to here. So beyond that, when you will laminate any bare rod, the heat loss will reduce. Or below this shaded region, okay, the heat loss will what happens? See here, green layer shaded region is coming below the dot line. It means that the heat loss is decreasing. When it is crossing the dead dot circle line, again the heat loss reduces. Okay, so maximum heat loss taking place at the this dotted over the dotted circle line. So this is why where it is used. It is mainly used where the electrical cables, where the maximum heat loss we want to remove, otherwise melting of this wire will take place. Okay, see here we have a conductor, metal conductor, and over that we are having a thickness of insulation of certain thickness. See here, this is the our this is the this is our thickness. Okay, the same thickness I have shown here. Okay, insulation layer, why it is provided? It is provided to remove maximum amount of heat. So RC is equal to K upon H naught. When you will put at this value, okay, K is what? Thermal conductivity of this. H naught is what? H naught air का. इसके around this wire we are having a wire air of thermal conductivity H naught. So when you will divide it, you will be getting RC. So when RC is just at the dotted line or laminate or the thickness of this insulating layer is overlapping this dotted line, it means that maximum heat loss will take place. Okay, so let's again. So if the say if the thermal conductivity, let's I have kept at here. Okay, the heat loss is reducing. Okay, so now I am going to change the K value, means K of this thermal conductivity of this wire. When you will reduce it, see, the RC will reduce because RC and K are directly proportional. So okay, so when you will increase the RC, again when you will increase the RC, again what will happen? RC will reduce. Okay, so now see the how the values changing. So this dotted line, just you bring the green shaded region, okay, or adjust the insulation thickness over this dotted circle. See, reduce it. Okay, now what is showing it is insulation radius heat loss reduces. Just make it perfect overlap. Okay, so heat loss is maximum. It means that the maximum loss is taking place here. So this is the condition, this one. Okay, here these conditions. Okay, so insulation radius Ri, this is nothing but the bare rod radius. Okay, so just similarly you can see for the sphere case also. In the sphere case, what we had seen, so RC is given as K, RC is given as what? RC is given as 2K upon H naught. Okay, so this formula we had seen for the case of sphere. Okay, so the for calculating the RC, okay, this formula in the animation see here, sphere condition I have taken. So RC is equal to 2K upon H. So for the time being here I have kept suppose 0.5 and suppose 20 H value I have kept. So 0.5 divided by 20, how much you will be getting? You will be getting something like this. Okay, 0.05. Okay, for the case of a sphere. So again, since RC and K are directly proportional, more is the K value, more will be the RC. See, the RC is increasing. Okay, see in the at the horizontal x-axis, okay, we are having a radius. So more is the H value, less will be the RC. Okay, now insulation thickness, see, I am increasing. This dotted line again, what it is showing? Dotted line showing that at this up to this radius of insulation thickness, maximum heat loss will take place. Just overlap this means we have laminated this bare wire up to this thickness. Okay, so what is happening if I increasing the thickness over the bare rod? What is happening in the graph? The heat loss is increasing, which we had seen here. Heat loss was increasing. Okay, again increase the insulation radius, heat loss is increasing up to where it will increase up to 0.047. See at the horizontal x-axis 0.047 means up to here somewhere here. Okay, after that the heat loss will decrease. Okay, now first it will increase. See the status showing in insulation increase heat loss. Now it is increasing. Now as soon as it will overlap, okay, so heat loss is maximum. This yellow shaded region means only the insulation thickness is optimum up to this level. Okay, beyond, if you will increase the thickness of insulation, what will happen? It will decrease according to the graph which we had studied in the book. Okay, just you increase the start increasing the, okay, means you are crossing the shaded circle region. So now the insulation reduces heat loss. Okay, so this was all the concept of what? Critical thickness, how we insulate the bare rod. Generally, bare rod or wire is insulated for maximum heat loss so that no hazardous or no melting of the electrical wire cables takes place. Okay. Now again, where we need then small heat loss in case of steam when we pass the through the pipe. Okay, where we don't need any losses of steam heat loss. Okay, similarly you can change the initial radius, means bare rod, or here the case of a sphere, if you are increasing the radius, see what is happening, the heat loss is decreasing, just you reduce it. Okay, so see here, just you reduce it. Okay, now the heat loss is something like this. Okay, similarly you can play with this. Okay, K. Okay, now H also you can play with H also. Okay, So that was all about the sphere case and the cylinder, why we provide and how we provide critical thickness. Okay, and what is the reason why we provide. Okay, to reduce the maximum heat loss. Okay, up to RC, heat loss increases. Okay, which we had seen in the case of cylinder. See here, so what we had seen here, the RI I have set here. Okay, RTA. See what we had seen. So as we are increasing the thickness of insulations, see here the heat loss is increasing. Okay, see the status showing is in the red text, increasing up to this dotted line. RC is what? 0.058. See here, when you will drop a vertical line at 0.0587, okay, you will be getting the maximum, what, maximum heat loss maximum. This is the conditions. Okay, beyond, if you will increase the thickness of insulations, means beyond dotted line, when you will insulate or put a rubber over the bare rod, okay, the heat loss will decrease. See, after this, heat loss is decreasing. So that was all about the critical thickness of insulations. Okay, so thank you all.